Hi, this is my final, the game of mess, not chess, and if I sound groggy, it's because I am. I just it's the morning, but yeah, and if you hear some papers, it's I got like a talking points just in case, but yeah, let me start. So here's the main function right here, and I made use of the chess class by making a chess variable and I call the start function from the chess class here. Basically, the whole game is in that start right here. And it's a do while loop and it repeats this next move function while the game over function reads false. If it reads true, then it's game over. It ends the loop and ends the game. But yeah, it'll just keep repeating this next move. And the first thing that the next move function does, it calls the checks turn function. And in that the checks turn function, it basically just sees whose turn it is, which like black or white, and it also changes whose turn it is as well for the next turn. Like if it's white this turn, I'll make sure it'll be black next. If it's black this turn, then I'll make sure it's white next. So, and then the rest of the function is basically all in his do while loop, while it in it's in his do while loop while it reads the valid moves fall. If it's an invalid move, basically. And if it's invalid, then I'll just do this all again until the user picks a valid move. And right here you can see I made the boolean right here and it goes false. And right here is the header for is the header. Basically, it reads out to the user. And sorry, I'm just checking my papers and after that I call it the display board function, which is in the board class. There it is, right here. And then the display board function, the first thing I do is I put the width and the height right here. So I know how I want how big the spots I want to be on the board. How big, how wide, how tall the squares are. And to create the board, I basically just use for loops. You can see all these for loops, and the modulus operator. I'll take advantage of that as well. So I know where to put the numberings on the side. Where to put the lettering of the piece names, and the numbering on the bottom as well of the board. And as the for loops read, it'll keep like as it goes through the numbers, the modulus operator will check and if it ever equals the remainder, then I'll put the numbering or the name of the pieces on the board. And you see this prints the side right here with the numbering, and then this prints the rest of the board right here. And then for the bottom for the number on the bottom and everything, it's down here. And go back to the actually let me go back and make a point. And here's the first time you'll notice game board. And game board is what I created up here. It's a pointer basically. Oh, it is a pointer. And so it has all the information for all the spots. As you can see right here, I make all the spots equal 0. And then down here is when I start placing the pieces. Like for the pawns, I put it in the loop since it's all on the line already. And then down here is where I put all the rooks, knights, bishops, queens, and kings. And that's the same here as with the whites. And right here is the destructor for the board. So it deletes all the spots and resets them back to 0. Let me go back to the next move function. Sorry. And right here is where it gets the input from the user. I basically ask for the just put in the numbers for the row and column. And then when I get that that input to get the row, I just divided by 10. And so I can get so I know the tenths basically of what number they put in, and I also have to or subtract by 1 since and an array starts with 0 instead of 1. And that's how I get the row. And for the column, I use the mod operator again. So I know the remainder. So I know the second number, the column number. I also have to subtract the 1 as well. And I do the same with the end spot. And down here is basically it's a bunch of checks to make sure that to make the move valid, basically. Like this is to make sure the move is within the board, it's not outside. And down here is where it gets the color to make sure that it matches the player. And here it gets the get color function. And that's all the way in the piece class. Now you go to and show. And right here, get color. All it does is just return the piece color. That's all it does. And I don't know if you saw, but the next check will be to check legal moves, which is also right here. You can see. I made it as a virtual boolean. You can see in private that it calls this right here. It's within the legal moves of the legal moves function within the piece. And so it's basically it basically just call like it gets the piece color, get color. It just does it checks the color, and if it's the end spot is 0, and calls this virtual boolean, which is in every piece basically. You can see right here down that this is the piece legal moves, and it's also in bishop and just make sure their moves are legal as well. It's in every piece. Just going back to the next move, sorry. Yeah, you can see right here where it calls the legal moves function from the piece class. And after it checks the legal move, I create a temporary pointer that equals the end spot and makes the start. The start spot equals 0 basically. And yeah, and this is where it makes the move. And right here is to check if the player is in check or not. And if it reads false, then the move is true. Yeah, they can perform the move. But if it reads true, then I'll undo the last move. Right here, you can see. Just make the star spot read the It'll go back to the start spot again. And then it says the move's invalid, and then we'll just go back to the beginning of the do loop and make you input the and input the another move, a valid move, as you'll say. And so that's it for the next move. And after that, it if the move's valid, it goes to the game over function to see if it's true or not. If it's game over, if it's not, here. Sorry, let me just check my paper. Make sure. All right. So I'm basically making a Boolean can move and equals false, and it calls the can move function in the board class. And let me go and show that right here. So I go through all the pieces, basically, right here, and if it is the piece of the player, it checks if it's a legal move as well. You can see it. I call the get color to make sure. And then here is I check the legal moves as well. And this is this is basically checking. I'll check the move and check whether the king is in check. You can see right here, it calls the checkmate function. And the checkmate function is right up here. And the checkmate function, within it, I first find where the king is, which spot it is. And checks the color of the king to make sure, checks if it is the king to be safe. And then after I find the king, the row and column, which should be just in the same spot, it runs through this goes through the opponent's pieces, see if any can take the king. Basically, there's some checks again as well, like get color, legal moves, and it turns true if it can, and false if it can't, for the checkmate. And if it's not checkmate, then the can move will basically be true. They can still move, and it'll just return true. And if it returns true, it'll say that it'll basically say game over is not game over is not false, or it's false. It's still ongoing. But if can move is false, it will read this. Basically, it'll say checkmate. I'll check whose turn it is, and it'll be like checkmate, player turn wins. Or it'll say stalemate if neither. Okay. So this is basically the game over function. And yeah, that's what I'll read. Sorry, I'm just checking my paper, make sure I want. Well, yeah, that's the whole game. Here, I'll show you the moves as well, or the pieces, the legal moves. Sorry, I just saw that on the paper. Yeah, so go to that virtual Boolean. That's piece legal moves. That's in all the piece classes, like rook, rook and knight and everything. And right here you can see this is pawn, so it's not much. Honestly, this is like if the spot's unoccupied, like just enter that spot. And this is if the spot was opposite color. We'll take it. If not, then yeah. If it can't return true for any of these, they'll just return false and say the move's not legal. And here's the bishop. It's a bit more complicated than than just the pawn. So the pawn is just a simple move up. And for this one, actually, I made a switch rows and switch columns. Since you're going in between rows and columns, I made a for loop that it basically checks the rows and checks the columns. And this basically right here, if the check row does not equal the end row, it'll keep moving the piece to the desired spot, switching the rows, switching the columns, and until it does. And if sorry, I'm getting a little sick. And yeah. So it'll keep reading that. And it'll go between all the spaces, and I'll make sure this to make sure all the spots are just empty. See, like if it doesn't read 0, then it returns false. But if it can go to that it can go to that spot without any interference from any other pieces, then it'll return true. So and and that move is legal. It's possible. Same with rook. With the switch columns and switch rows, and make sure all the in-between spots are empty for both of these, for the columns and for the rows. If you want to like go across columns, you can check right here. You can see check column until it goes to it will keep reading this until it goes to the right spot, to the end spot where the user wants to end up. And if it can't up there, it'll return false. If it can, it'll return true. And this is for the rows basically too. So it'll just it'll go all the way to it'll keep jumping the rows until it gets to the until it gets to the spot as well. If it can't, return false, but if it can, it'll return true. And since this is the chess, this is in chess, it's the mess, and you can't I guess in mess you can't move knight, queen, or the king. Any move, sort of any move, any of those pieces is false, so they can't move any of those. That's right to the user down here as well. King, queen, and knight cannot move. So yeah, it's my mess program. Hope you enjoyed it. And yeah, thank you.